Good morning, everyone. This is Mrs. Padmashri from SNS College of Engineering, Department of Artificial Intelligence and Data Science. Today, I am going to explain you the topic in machine learning called EM algorithm. Let's go to the topic. What is EM algorithm? So, EM algorithm is one of the most commonly used algorithm in machine learning. So as we discussed earlier, there are many algorithms available in machine learning: supervised algorithm, unsupervised algorithm, reinforcement algorithm, etc. So mainly this algorithm plays a vital role in unsupervised machine learning algorithm. So how this algorithm will be helpful for unsupervised algorithm? Let us watch this video. So this is important algorithm in machine learning in order to find out the maximum likelihood estimation of variables. So here in this algorithm, fully we are dealing with the variable. There are two types of variable that we are going to discuss. One is the observed variable and the other one is unobserved variable. So from the name we can easily find it out what is this observed variable, where we can able to predict those values of the variable, that is called the observed. And unobserved, we cannot predict the values of the variables, that is called the unobserved variables. So it is also applicable, this EM algorithm is also applicable to unobserved data, or sometimes it is called a latent. So remember unobserved variables or unobserved data are called latent variable. So why this algorithm is needed? First of all, the question arises. So you can easily find it out. Whenever we train any algorithm in the machine learning, we'll be using the data set, right? So in those data set, mainly the first step that what we will do is uploading, or you will import the data set. Then we will do the technique like a pre-processing technique. We'll apply the pre-processing. There, why we need the pre-processing? Like we will be having some unwanted data also in the data set, right? So it will affect the performance of the machine learning algorithm. So the pre-processing step is very important step in machine learning. So this unobserved data, like where we cannot predict the value of the variables, will affect the machine learning performance. So that has to be noticed, and we have to maximize the value of those variables. Then we can improve the performance of our algorithm. So this area is very important. Like this only we are going to improve the performance of the machine learning algorithm. So EM algorithm helps for that, has many real world application in statistics, including finding out posterior marginal distribution of the parameters, both in machine learning and data mining application. So real life applications of machine learning, mainly it is used in many fields like data mining applications, and relevant learning features are available, but very few of them are observable, and the rest are unobservable data. So the next will be, if we know that if the variables are observable, then we can able to predict the values of instances. Okay, so the variables are not observable, which means unobservable, it is called a latent variable. Okay, so the variable which are latent or directly not observable, for such variables EM algorithm plays a vital role to predict the value, with the condition that the general form of the probability distribution of those latent variables should known to us. Okay, so this is very important point that we should notice. The unobserved variable, the probability distribution of those variables should be known to us. So we will discuss the basic introduction of this EM algorithm, a flowchart of EM algorithm, and its application, advantage as well as disadvantages of EM algorithm in this video. The next will be What is an EM algorithm? Expectation maximization algorithm is defined combination of various unsupervised machine learning algorithm. So we had been discussing so far about supervised machine learning algorithm. There are so many algorithms so far we have discussed in our video, and this EM is especially we are going to use it in the unsupervised, like k-means algorithm, k-means clustering algorithm. Okay, mainly used to determine local maximum likelihood estimation. So we can also call this as MALE or MLE or maximum posterior estimates, mainly for unobserved variables in statistical model. So it is a technique to find maximum likelihood estimation when the latent variables are present in the dataset. It is also referred as latent variable model. A latent model consists of both observable and unobservable variable, where observable can be predicted, unobserved or inferred from the observed variable. Okay, also called as latent variable. Next, we will discuss about what is this EM algorithm. It's a combination of various unsupervised machine learning algorithm such as k-means clustering. Being an iterative approach, it consists of two modes. The first mode, we estimate missing or latent variables. It is referred as expectation step, E step. The first step is referred as E step and the second step is referred as M step. We'll see what is that. So E step, what is called E step? Expectation step, or we can also call it as expectation estimation step. The other mode is used to optimize the parameters of the model so that it can explain our data more clearly. The second mode is called as maximization step, or simply we can call it as M. M for maximization, E for estimation. You can remember like this. So the second step is maximization. See, you could see here there are two steps involved here. One is the M step, other one is the E step. The first is E step, right? What is this E? Expectation, or we can say estimation. And M is called as maximization, or we can call it as simply M step. So here you can see here, update the variable. The first step, you're going to do variable updation. So we can transfer the data to the second step, which is called the maximization. So here what is happening here is update the hypothesis. Then again the result we are going sending back to the first step. So this was happening in the steps of EM algorithm. In briefly we'll discuss about what is this expectation step, what is this maximization step. So expectation E step involves estimation of all missing values present in the data set, so that after you complete this step there should not be any missing values. See, why you should not have missing values in the data set? Because it will affect, as we already said, a data set should be pre-processed. Okay, if we did not notice this missing value, it will create a problem in the algorithm, like it will occupy the spaces, and it will affect the performance of the algorithm. So clearly notice missing, we have to mitigate this missing values. Maximization, M step. What this step involves? The use of estimated data, okay, present in the E step and updating the parameter. So estimated data will be sent from E step to M step. So this analyzes the estimation data in E step and updating the parameters in M step. Repeat this two steps continuously until the convergence of your value occurs. The next we will be discussing in the next video. The continuation will be discussed in the next video. EM algorithm continuation. Thank you.